Refraction of light. Now, what does it mean, refraction of light? If this is, suppose this is your glass slab, okay? Now, this is the normal, that is normal is what? Perpendicular to the surface. So when a beam of light comes from rarer medium to the denser medium, okay, then when a beam of light comes from rarer medium to denser medium, then it will move towards the normal. If this is your normal, if this is your normal, then light will move towards the normal. When a ray of light comes from denser to rarer medium, it will move away from the normal. Now, what does it mean? Denser to rarer medium. Now, what do you mean by this? Rarer medium, denser medium, again rarer medium. What does it mean? According to our molecules, now come to the chemistry part. According to the molecules of interaction, air interaction is less denser as compared to your glass intermolecular force of attraction. Air is not gaseous, so its molecular density is less as compared to your glass one. So air is known as rarer medium and glass slab water is known as what? Denser medium as compared to air. So when a beam of light means what? Incident ray. When an incident ray, suppose takes an angle from the normal, suppose 45 degrees, suppose. When it comes to the denser medium, it may be, this angle is known as what? Refracted angle. Refracted angle. Suppose my refracted angle is, take it as 30 degrees. So it will be less. This angle is equal to this angle. This is also 30-degree angle. Now, when a beam of light coming out from the denser medium to my rarer medium, then this angle can be 50 degrees, and this angle is known as emergent angle. And this ray is known as emergent ray. This ray is known as what? Refracted ray. Okay, now if suppose I am taking the angle, I am just taking this straight line. I have extended my incident ray. Okay, now the distance between the refracted ray and your incident ray, the distance is known as lateral distance, lateral inversion. The distance from your incident ray and the emergent ray is known as what? Lateral inversion. Now here are the rules that you should have to know. First rule.
Ma'am, is it possible to give a brief explanation about it again?
Of yours. Now first rule. When a ray of light comes from rarer to denser medium, then the ray of light will shift towards normal. First point. Second, when a ray of light comes from denser to rarer medium, then the ray of light will shift away from the normal.
Okay.
Fine. The distance between, third point, the distance between incident ray and emergent ray is called lateral inversion. Fourth point. The ray of light which comes from denser to rarer medium then that ray of light is called emergent ray. Note in this case, why I have written in this case? See beta, emergent ray is that ray when the ray travels down two different mediums. Suppose if I have taken this is as a denser medium, this is as a rarer medium, and this is as a denser medium. Now, ray of light comes from denser to rarer medium. The ray of light will move away from the normal. Correct?
Yeah.
Correct? Now, when the ray of light comes from rarer to denser medium, it will move towards the normal.
Yeah.
Okay, so that ray of light is known as what? Emergent ray that in that case. But here, in this case, what is the thing is there? The ray of light comes from rarer to denser medium. That ray of light is known as what? Refracted ray. Now the ray of light comes from denser to rarer medium. That ray of light is known as what? Emergent ray. Okay, now.
Okay. So the
Now,
emergent rays go away from the normal, right?
the third party. Emergent ray is what? The third party. This is your first party. This is your second party. This is the third party. So whenever the third party ray of light comes out, that ray of light is known as what? Emergent ray. First party is having what? Incident ray. Okay. Second party is having what? Refracted ray. And the third party is having what? Emergent ray. Clear?
Oh, yes, ma'am.
Fine. Now the last point. Fifth, when the emergent ray, most important point, when the emergent ray becomes 90 degrees to the normal, then that angle is known as critical angle. Six, what does it mean, critical angle? Right now, my angle is how much? 50 degrees. Now, suppose if my angle has become this way, like this. It means this is totally perpendicular to my normal. Then this 90 degree is known as what? Your critical angle. Understood?
Yes, ma'am.
When it is 90 degree with the normal, if my emergent ray is 90 degree with my normal, then it is known as what? Critical angle.
Okay.
Clear? Now, what does it mean? Reflection of light is in same medium. Light comes, hits the surface and bounces and then reflected back with the same angle of the incident ray. But in refraction of light, it is of what? Two different mediums. We are talking about two different mediums.
Yeah.
Is that clear? Refraction.
And which are the two different mediums again?
In reflection, light travels in same medium. Angle I is equals to angle R. I, R and normal all lie in same plane. Correct? But in refraction, light travels in two different medium. Okay?
But which are the two different mediums?
Rarer medium and denser medium.
Okay.
That is rarer and denser medium. Okay? Now,
Yeah.
angle I is less than angle R. Or you can say angle I is greater than. First make it as a greater, then lesser I will say. Angle I is greater than angle R. It means that light travels from rarer to denser medium, right? And angle I is less than angle R. It means light travels from denser to rarer medium. In this case, R is known as what? Emergent ray.
Yeah.
And when this emergent ray becomes 90 degrees, then that is known as what? Critical angle.
Okay.
Clear? Any doubt?
No, ma'am.